Hello friends, I am RM Guru, working as Assistant Professor in Sharjah Institute of Technology, College of Engineering. I am dealing with Surveying 1 course. Today we are going to see how to make use of compass. So this slide refers to figure of survey compass, in which on the left part there is a eye-vane, on the right part there is a guide-vane. By making use of eye-vane and guide-vane, we can establish a line of sight. The bubble tube are placed making an angle of 90 degree to each other. It is provided inside the compass box or outside the compass box. Magnetic needle is also provided, and there is a fixed graduated plane over which the graduations are marked is also there, showing north, east, south, west. Again, the compass is attached with the tripod by making use of ball and socket arrangement. This slide refers to temporary adjustment of compass. The following operations are to be carried out as a temporary adjustment. They are centering, leveling and focusing. Focusing includes adjustment of prism and bisecting or observation of bearing. This slide refers to temporary adjustment of compass. It is also called as station adjustment because they are to be carried out at a particular station. It includes centering, leveling and focusing. In the centering, the center of the compass is placed vertically over the station point by dropping a small piece of stone below the center of compass. It falls on the top of pegs marking that station. So in this operation, we are trying to bring center of the compass over the point which is marked on the ground with help of peg. Then the second operation is leveling. By means of ball and socket arrangement, the compass is leveled so that the graduated ring swings freely. It may be tested by rolling a round pencil on the compass box. So whenever we are checking the leveling, we are supposed to place the round pencil. If it doesn't roll, then we are going to say that the compass is leveled. And third operation is focusing. So whenever we are trying to make use of the prism in order to record the bearing of a line, the care is taken that first of all the line of sight has to be established, and after that looking through the prism by moving up or down position till the readings are seen to be sharp and clear, you can record the bearing of a line. So in this slide we are going to see the observed bearing. The compass centered over station A of line AB and is leveled. Having turned vertically the prism and sighting vane, raise or lower the prism until the graduation of the rings are clear and look through the prism. Then turn the compass box until the ranging rod at the station B is bisected by hair and look through the prism. When ranging rod B comes in line with the slit of eye vane and the vertical hair of the object vane, the reading is taken through the prism which gives the bearing of line AB. This slide refers to permanent adjustment of prismatic compass. It is divided into three adjustments. One is adjustment of sight vane, second is adjustment of needle, and third is adjustment of pivot. In the adjustment of sight vane, the object is to bring the sight vane into a vertical plane when the instrument is leveled. For this, we have to level the instrument properly, suspend a plumb bob line at some distance and establishing a line of sight. Then in the adjustment, if the vertical hair in the object vane is not seen parallel to the plumb line, remove the affected vane and either file the higher side of the bed or insert a suitable packing under the lower side. So this way you can do the adjustment. Then second adjustment is adjustment of needle. The needle is adjusted for sensitivity. It is adjusted for balancing the needle, straightening the needle vertically and straightening the needle horizontally. This slide refers to permanent adjustment of prismatic compass, and in this adjustment we are doing the adjustment of pivot. The pivot must be exactly in the center of graduated circle. To test it, bring the north end of the needle against the north 0 degree mark of the graduated circle and note the reading of south end of the needle. Now bring the north end of the needle exactly against 90 degree and mark and note down the reading of the south end. This slide refers to comparison between prismatic and survey compass. In the prismatic compass, the horizontal angle made by a line with the magnetic north in the clockwise direction is measured and it is called whole circle bearing of line. Whereas in case of survey compass, the horizontal angle made by a line with the magnetic north or south, whichever is closer in the eastward or westward direction, or in clockwise direction or anti-clockwise direction, is called quadrantal bearing or reduced bearing of the line. In case of prismatic compass, the clockwise angle from the reference line or reference north is taken, whereas in case of surveyor compass, both magnetic north and south lines are considered as a reference line in quadrantal bearing system. Both clockwise and anti-clockwise angle from the reference line are taken, which are least. In case of prismatic compass, the value of whole circle bearing varies from 0 to 360 degree, whereas in case of surveyor compass, the value of reduced bearing varies from 0 to 90 degree. The prismatic compass bearings are written like this, that is 26 degree, 121 degree to 45 degree and 350 degree. Whereas in case of surveyor compass, the bearings are written by making use of quadrant, where the needle is going to fall. For example, N 26 degree east. This is the line which is lying in the first quadrant. Then S 59 degree east. This line is going to fall in the second quadrant. S 65 degree west. This is a line which is going to fall in the third quadrant. And N 10 degree west. It is a line lying in the fourth quadrant. This slide refers to temporary adjustment of compass. It is also called as station adjustment because they are to be carried out at a particular station. It includes centering, leveling and focusing. In the centering, the center of the compass is placed vertically over the station point by dropping a small piece of stone below the center of compass. It falls on the top of pegs marking that station. So in this operation, we are trying to bring center of the compass over the point which is marked on the ground with help of peg. Then the second operation is leveling. By means of ball and socket arrangement, the compass is leveled so that the graduated ring swings freely. It may be tested by rolling a round pencil on the compass box. So whenever we are checking the leveling, we are supposed to place the round pencil. If it doesn't roll, then we are going to say that the compass is leveled. And third operation is focusing. This slide refers to whole circle bearing and quadrantal bearing. Generally, the range of whole circle bearing is from 0 to 360 degree, and whole circle bearing is measured from reference north, and it is always measured in a clockwise direction. Whereas in case of quadrantal bearing, maximum value of angle is at the most 90 degree, and it is measured in a clockwise direction or anti-clockwise direction. It is also measured from north and also measured from south, depending upon the line where it is located. So this slide refers to whole circle bearing conversion to reduced bearing. So here the point at which the compass was set up is O, and the line is OA, and therefore the whole circle bearing of the line is lying in the third quadrant, that is southwest quadrant. Therefore, whenever we are going to measure or calculate the reduced bearing, it is very near to south. So therefore, the psi angle can be taken as an angle, whereas since that particular OA line is lying in the southwest quadrant, therefore we have to write the whole circle bearing of a line as S psi W. This slide refers to conversion of whole circle bearing to reduced bearing. 4 lines are shown in each quadrants having the WCB alpha, and we are interested to calculate what is the reduced bearing of a line. So let us consider the first line which is lying in the first quadrant having the WCB alpha. So the conversion of WCB to reduced bearing when the line lies in the first quadrant, that is alpha equal to psi, where psi is the reduced bearing of a line which is lying in the first quadrant. Then let us consider the second line which is lying in the second quadrant having the WCB alpha. So Whenever we are going to calculate the reduced bearing, it is to be calculated as 180 degree minus alpha equal to psi, where psi is the reduced bearing of a line. Similarly, when the line lies in the third quadrant, since the value of WCB exceeds 180 degree, so from the WCB we have to subtract 180 degree to get the reduced bearing of a line when it lies in the third quadrant. Similarly, we will consider the next line which is lying in the fourth quadrant, that is northwest quadrant, and the value exceeds 270 degree for WCB. Therefore, in order to calculate the reduced bearing, we have to subtract the WCB from 360 degree to get the reduced bearing of a line, since we are going to measure the reduced bearing which is nearer from north. In this slide, we are going to see how to convert the reduced bearing to WCB. In the given figure, 4 lines are shown in each quadrant, namely northeast quadrant, southeast quadrant, southwest quadrant, and northwest quadrant. The line lies in the first quadrant has reduced bearing of psi. So therefore, in order to get the WCB in the first quadrant, psi equal to alpha. So alpha is nothing but it is WCB of a line. Then we will consider the next case when the line lies in the second quadrant, that is southeast quadrant, and psi 1 is the value of reduced bearing. So in order to calculate the WCB, we have to subtract psi 1 from 180 degree to get the WCB of that particular line. Similarly, if we are going to consider the line lying in the southwest quadrant having the reduced bearing psi 2, then in order to calculate the WCB, we have to add psi 2 to 180 degree to get the WCB of a line. Similarly, when you consider the line lying in the fourth quadrant, that is northwest quadrant, then in order to calculate the WCB of a line having psi 3 as a reduced bearing, then we can calculate the WCB as 360 degree minus psi 3. In this slide, we are going to see declination and inclination. So declination is nothing but it is the horizontal angle between true north and magnetic north, whereas the dip of the needle is nothing but it is the vertical angle between the horizontal position of the needle and inclined position of the needle. So we will see more about magnetic declination. So it is the angle between the true north and magnetic north, and therefore it is called declination or variation. This angle may be computed approximately from the location of north magnetic pole. Declination value represent the error between the magnetic north and true north for a specific location. Declination degree values can be either expressed as easterly or westerly, or as positive or negative. Easterly declinations are represented as positive, whereas westerly declinations are represented as negative values. This slide refers to variation in declination. Declination at any point does not remain constant but keeps on changing from place to place and time to time. Their variations may be classified as under diurnal variation, annual variation, circular variation, irregular variation. Depend upon where you are, the angle between the true north and magnetic north is different. In the US, the angle of declination varies from 20 degree west in Maine to 21 degree east in Washington. The magnetic field lines of the earth are constantly changing, moving slowly westward 1 up to 1 degree every 5 years. So in this slide we are going to see what are the types of errors observed during the compass. The errors may be classified as instrumental error, personal errors, and error due to natural causes. So in this slide we are going to see what is local attraction. The magnetic needle always points towards magnetic meridian when it is freely suspended and truly balanced on a pivot. But when the compass is set up on the field in the presence of iron or steel structure or any high voltage current, then the magnetic needle will not point towards the magnetic north, but it will be reflected from its normal position. This deflection of the needle from the magnetic north under the influence of magnetic substances is known as local attraction. So, when the survey stations are affected by local attraction, the measured bearing should be corrected before plotting the traverse. This slide refers to forebearing and back bearing. So bearing taken in a forward direction of survey line, it is called fore bearing of a line, whereas bearing taken in backward direction of survey line is called back bearing of a line. So here in the figure, in the first figure, the instrument is set up at A, whereas the ringing rod is held at B. So the reading is taken in a forward direction AB. So therefore FOB, it is called fore bearing of a line. In the second sketch below, at station B the compass is set up and at A the ringing rod is held. Since we are going to record the bearing in our backward direction, this particular bearing recorded is called back bearing of line AB. Now we will see the local attraction and how to detect the local attraction. So the error induced in the direction of magnetic needle due to magnetic materials such as iron ore, steel structures, electric cables conveying current, etc., then it does not show the actual north. This phenomenon is known as local attraction. So in order to identify whether the particular station is affected by local attraction or not, so for that we have to take the difference between fore bearing and back bearing, and if the difference is exactly 180 degree, then we can call that particular station as free from local attraction. And if the difference between fore bearing and back bearing is not exactly equal to 180 degree, other than 180 degree, then we can say that the given station is affected by local attraction and it carries the error of local attraction. So we have to divide the error in fore bearing and back bearing whenever we observe the local attraction at a particular station. This slide refers to sources of local attraction. The needle of the magnetic compass may be affected by following sources. One is natural source. It includes iron ores, magnetic rocks. Secondly, the artificial sources: steel structures, rails, iron pipes, electric lines, metallic chain, steel tapes. So these are the sources of local attraction. So this slide refers to whole circle bearing conversion to reduced bearing. So here the point at which the compass was set up is O and the line is OA, and therefore the whole circle bearing of the line is lying in the third quadrant, that is southwest quadrant. Therefore whenever we are going to measure or calculate the reduced bearing, it is very nearer to south. So therefore the psi angle. Then in second method, in this method unaffected line is first detected from the given reading by considering the fore bearing and back bearing. Then starting from that line, the bearing of other affected lines are corrected by finding out the amount of error at each stations. If no angle is differ by 180 degree in its fore bearing and back bearing, then select a line in which the difference of fore bearing and back bearing is nearer to 180 degree. Then find out the mean value of bearing of that line by applying half the correction to both fore bearing and back bearing of that particular line. The modified bearing will be differ by 180 degree. So proceed with modified bearing to find out corrected bearing of remaining lines. This slide refers to chain and compass surveying fieldwork. It is divided into recognition survey, preparation of index sketch, marking the station on the ground, locating stations, measuring and recording of survey lines, and measurement of bearing of survey lines. So in this slide, the instrument used for compass surveying is given. The various instruments used in compass survey are prismatic compass, chain, tape, ranging rods, tripod, plumb bob, and arrows. Thank you.